Hey everyone, in this video we're going to learn how to graph parent functions that have been translated. We're going to do that by first identifying the parent function, then figuring out the translation, and once we have our function graphed, we're going to determine the domain and range. Our first function, y equals the absolute value of x minus 5. So the parent function here is the absolute value function, y equals the absolute value of x. The translation, so we have x minus 5, so we're going to add 5 to the x values, 0 to the y values. If we had to describe this, we're going to say it's going to be moved to the right 5, and hopefully we see that to be the case when we graph. And now we can set up a table of values for the parent function. So we have -2, -1, 0, 1, 2. So our y values are 2, 1, 0, 1, 2. And y equals the absolute value of x minus 5. Okay, the way we're going to find the points for this translated graph is we're going to apply that translation of 5, 0. So we'll add 5 to each x coordinate, 0 to each y. So that gives us 3, 2, 4, 1, 5, 0, 6, 1, 7, 2. So we can plot these points. So we have 3, 2, 4, 1, 5, 0, 6, 1, 7, 2. I'm going to use the line tool so my graph is nice and neat. Need an arrow. So I'll start at the vertex and go through those points there. And then from the vertex through those points there. Okay, so we have the graph of y equals the absolute value of x minus 5. So we can see that it has been shifted to the right 5 units. And now we need to answer the domain and range question. So the domain, looking from left to right, is all reals, so -infinity to infinity. And the range, working from bottom to top, the lowest y value is 0, and it goes to infinity, so we'll go bracket 0 to infinity. If I wanted to express this as an inequality, it would be y is greater than or equal to 0. And that would be correct as well, since they didn't tell us it had to be an interval notation. So there's our first translated function. Next, we have y equals x squared minus 6. So our parent function is y equals x squared, the quadratic function. To figure out the translation, let's add 6 to both sides. So y plus 6 equals x squared. Right, the minus 6 isn't inside of the parent function. So our translation here is 0 minus 6. Right, the equation is y plus 6. We're then subtracting 6 from the y values. Again, to place emphasis, the equation is always telling us how to get from this graph back to the parent function. Our goal is to start with the parent function and get this graph. So we have to do everything in the opposite way. So the table of values for the parent function. So we'll use -2, -1, 0, 1, and 2 as the x values. So 4, 1, 0, 1, and 4 will be the y's. And we need to come up with the points on y equals x squared minus 6. So we're going to apply the translation of 0, -6. So we'll add 0 to every x value and subtract 6 from every y. So -2, -2. Let's fix that, -2. Then we have -1, -5, 0, -6, 1, -5, 2, -2. So we can plot our points. So -2, -2, 1, -5, 0, -6, 1, -5, 2, -2. And we can connect our points with a parabolic curve. So there we have the graph of y equals x squared minus 6. And we still see we have that vertex, we have symmetry. The domain of our function is all real, so negative infinity to infinity. The range, going from bottom to top, the lowest y value is negative 6, and it extends all the way up to positive infinity. So bracket negative 6 to infinity. Perfect. Moving on. Y equals the square root of x plus 2 plus 3. So our parent function here is the square root function. Y equals the square root of x. Let's first subtract 3 from both sides. So y minus 3 equals the absolute square root of x plus 2. So our translation is, so x plus 2, so we'll subtract 2 from each x value. And y minus 3 will add 3 to each y value. So we'll create the table of values for our parent function first. Now when setting up this table for the square root function, we want our inputs to be perfect squares. So we'll use 0, 1, 4, 9. Can't have any negative x values, and all the other x values would not be perfect squares. So y values would be 0, 1, 2, 3. Now we need to figure out what the points are on our translated graph. Okay, so we're going to apply that translation of negative 2, 3. So we'll subtract 2 from every x value, add 3 to every y. So we get negative 2, 3, negative 1, 4, 2, 5, 7, 6. So we'll plot our points. So negative 2, 1, 2, 3, negative 1, 4, 2, 5, and 7, 6. So we connect our points. So we have y equals the square root of x plus 2 plus 3. Notice I don't put an arrow at the point negative 2, 3 because that's where our graph starts. Right? There wasn't an arrow at 0, 0 on the parent function, so we wouldn't put an arrow at the point negative 2, 3 in our translated function. If we describe this translation, we would say that the graph has been shifted 2 to the left and up 3. And we can figure that out from our translation or looking at the graph. The domain here, working from left to right, the lowest x value is negative 2, and it continues to infinity. So bracket negative 2 to infinity. And the range, working from bottom up, lowest y value is 3, and then it continues to infinity. So bracket 3 to infinity. As inequalities, I'll write them out this time. The domain would be x is greater than or equal to negative 2, and the range is y is greater than or equal to 3. Remember, domain is the x values, so I used x in the inequality. Range is the y values, so I used y in the inequality. Next up, we have y equals x minus 4 quantity cubed minus 4. Our parent function then is the cubic, y equals x cubed. We'll add 4 to both sides, so y plus 4 equals x minus 4 to the third. So our translation, so x minus 4 means we're adding 4 to the x values. Y plus 4, we're subtracting 4 from the y values. Okay, add 4 to the x, subtract 4 from the y. Our parent function, set up that table of values. So we have x and we have y. We'll use negative 2, negative 1, 0, 1, 2 as our x values. So y is going to be negative 8, negative 1, 0, 1, and 8. And we need to figure out what the points are for the translated graph. Okay, so Let's apply that translation of 4, -4. So we're going to add 4 to the x's, subtract 4 from the y's. So we get 2, -12, 3, -5, 4, -4, 5, -3, 6, 4. So one of the points won't fit on our axes, and that's okay. That's going to happen sometimes. But we still have 4 points that do fit, and that should be enough to get our graph. So we have 3, -1, 2, 3, 4, 5, 4, -4, 5, -3, and 6, 4. Okay, so that point at 4, -4, that's the middle, so I'll start there. So we kind of go a little flat, and then through those points, and then down. So that's going to be y equals the quantity x minus 4 cubed minus 4. If we had to describe the translation, we would say it's shifted to the right 4 and down 4. The domain here, working from left to right, well, the arrows look like they go down, but they're going to continue out as well in the left and right directions. So all reals, -infinity to infinity. And the range, working from bottom to top, will be the same. All reals, -infinity to infinity. Our next function is y equals 5 plus the cube root of x minus 1. So our parent function is y equals the cube root of x. Now normally it's plus 5 after the cube root, so they've just changed the order. It doesn't change our approach. So I'll subtract 5 from both sides of the equation. So that leaves me with y minus 5 equals the cube root of x minus 1. The translation, so x minus 1, we're going to add 1 to the x's. Y minus 5, we're going to add 5 to the y's. Okay, so if we had to describe it before we graphed, we would say it's going to be shifted right 1, up 5. So we should make sure that our parent function is shifted right 1, up 5. So our parent function, let's create that table of values. Now because we're taking the cube root, we want our inputs to be perfect cubes. So -8, -1, 0, 1, 8 would be good inputs. And that will give us -2, -1, 0, 1, 2 as our y's. Then we have y equals the cube root of x minus 1. Let's write it the way the problem did. They put the 5 first. 5 plus the cube root of x minus 1. We got to figure out what those points are. So we'll apply that translation of 1, 5. So we have -7, 3, 0, 4, 1, 5, 2, 6, and 9, 7. So we can plot our points. So -7, 3, 0, 4, 1, 5, 2, 6, and 9, 7. So I'll start at the middle of the cube root function, so it goes up a little bit, and then through those points, and then down through these points. So that's y equals 5 plus the cube root of x minus 1. And it was shifted right 1, up 5. Our domain, looking from left to right, is all reals, -infinity to infinity. Our range, from bottom to top, is the same. It looks like those arrows are kind of flattening, but they're going to continue to go down and up infinitely. And there we have our graph. Now they're giving us a piecewise function. So graph the following functions based off the given graph of y equals f of x below. State the domain and range of each function. Okay, so this is y equals f of x. Y equals f of x, that's in red. So first they want us to graph y equals f of x plus 3. So this plus 3, it's not inside the parent function, so I'll move it to the other side. So y minus 3 equals f of x. So our translation there is 0, 3. Nothing to the x's, and we're going to add 3 to the y's. So we take each one of these 4 points and add 3 to their y value. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So I'll use the line tool to connect the points. So line tool, I want to make the line blue. Okay, so we'll go connect our points. So there we have y equals f of x plus 3. So the domain of our graph, so left to right, we're going from -8 all the way to 6. So bracket -8 to 6. And our range going from bottom to top, lowest value is 2, highest value is 8. So bracket 2 to 8. Now, if we wanted to write these as inequalities, it would be -8 is less than or equal to x, which is less than or equal to 6. And the range would be 2 is less than or equal to y, which is less than or equal to 8. So this is good review of how interval notation turns into inequalities, or the vice versa. And we get to see that domain is x, range is y when we're writing the inequalities out. The other function they want us to graph is y equals f of x plus 2 minus 7. So I'll add 7 to both sides. So y plus 7 equals f of x plus 2. So our translation there, so x plus 2 means subtract 2 from the x's. Y plus 7, subtract 7 from the y's. Okay, so that means we're going to move each point to the left and then down 7. So to the left, down 1, 2, 3, 4, 5, 6, 7. And then we have 2 to the left, down 1, 2, 3, 4, 5, 6, 7. 2 to the left, down 7. And then 2 to the left, down 3, 4, 5, 6, 7. Again, I'll use a line tool so that my work is neat. I'll pick green. So we'll connect each point. So there we have the graph of y equals f of x plus 2 minus 7. And domain, working from left to right, we're going from -10 all the way to 4, and the range, we're going from lowest is -8, highest is -2, so -8 to -2. 2 more questions. Describe the effect the transformation g of x equals the square root of x plus a, where a is a positive integer, has on the graph of the parent function. Okay, so the parent function is the square root of x. And the transformation here, so it's x plus a in the equation. That means we're subtracting a from x and 0 to y. We can put y instead of g of x if that's helpful. Now a is positive. That's helpful because we're not subtracting a negative number, which would undo the subtraction. So that means that we're going to shift the parent function, which in this case is y equals the square root of x, to the left a units. Now, a little bit more descriptive than we usually are. Usually we would just say a shift left a units, and that's fine. But just writing it out a little more formally for this question. Now the next question, the maximum point on the graph of y equals f of x is 4, 10. What is the maximum point on the graph of y equals f of x plus 5 minus 8? So they've translated the graph they gave us, and they want to know what happened to this point. Well, we've essentially done that with the table of values. Now they're just asking us to do it with one single point, so it's actually easier. So first thing, let's add 8. So we have y plus 8 equals f of x plus 5. So our translation, x plus 5 means we're subtracting 5 from x. y plus 8, subtracting 8 from y. Okay, so then all we have to do is start with that point 4 comma 10, do that translation, and get our new maximum point. Okay, so we'll subtract 5 from the x, so that would be negative 1. Subtract 8 from the y, that's going to be 2. So our new maximum point is the point negative 1, 2. So we did more work with translations in this video. In particular, we were looking at graphing. Identify the parent function, identify that translation. If we can do those two things, then it's just a matter of taking the points from the parent function, translating them correctly, and putting them on our graph. And then we followed it up with a few thinking questions. So, take this opportunity to go practice with this before moving into the last video on translations. Click the Amazon link down below for my algebra workbook so you can practice on your own. Give the video a like, and before you go, click that subscribe button so you can see more videos just like this. Thanks for watching.